Hello everyone, I welcome you all to Lalpur Khalsa College Online Pathshala. Today's lecture is on the topic types of operating system. In my previous lecture I have discussed what is an operating system and today we will be discussing its various types. So let's start. Since we know operating systems are there from the very first computer generation and they keep evolving with time. In this lecture we will discuss some of the important types of operating systems which are most commonly used. So basically we have a number of operating systems, some of which are like batch operating systems, time sharing operating systems, distributed operating systems, network operating systems, and real-time operating systems. So I will be discussing all these type of operating systems one by one. So the very first figure shows batch operating systems. Now what are these? The users of a batch operating system do not interact with the computer directly. Each user prepares his job on an offline device like punch cards and submit it to the computer operator. To speed up processing, jobs with similar needs are batched together and run as a group. The programmers leave their programs with the operator and the operator then sorts the programs with the similar requirements into batches. These were the first type of operating system and they are being used. But they have some problems. The problems with batch systems were, number one, the lack of interaction between the user and the job. Number two, CPU is often idle because the speed of the mechanical input-output devices is slower than the CPU. And number third, it is difficult to provide the desired priority. Now moving on to the next type of operating systems that are called time-sharing operating systems as shown in the figure. Time sharing is a technique which enables many people located at various terminals to use a particular computer system at the same time. Time sharing or multitasking is a logical extension of multi-programming. Processor's time, which is shared among multiple users simultaneously, is termed as time sharing. The main difference between multi-programmed batch systems and time sharing system is that in case of multi-programmed batch systems, the objective is to maximize processor use. Whereas in time-sharing systems, the objective is to minimize response time. Multiple jobs are executed by the CPU by switching between them, but the switches occur so frequently, thus the user can receive an immediate response. For example, in a transaction processing, the processor executes each user program in a short burst or quantum of computation. That is, if n number of users are present, then each user can get a time quantum. When the user submits a command, the response time is in few seconds at the most. The operating system uses CPU scheduling and multi-programming to provide each user with a small portion of its time. Computer systems that were designed primarily as a batch systems have been modified to time-sharing systems. So the advantages of time-sharing operating systems are: number one, it provides the advantage of quick response. Number two, it avoids duplication of software. And number three, it reduces the CPU idle time. But also it has some disadvantages, which are: number one, the problem of reliability. Number two, question of security and integrity of user programs and data. And number three, problems of data communication. Now the third type of operating system is distributed operating system. These systems use multiple central processors to serve multiple real-time applications and multiple users, as clear from the figure. Data processing jobs are distributed among the processors accordingly. The processors communicate with one another through various communication lines such as high-speed buses or telephone lines. These are referred as loosely coupled systems or distributed systems. Processors in a distributed system may vary in size and function. These processors are referred as sites, nodes, computers, and so on. The advantages of distributed systems are: number one, with the resource sharing facility, a user at one site may be able to use the resources available at another site. Number two, speed up the exchange of data with another via electronic mail. Number third, if one site fails in a distributed system, the remaining sites can potentially continue operating. Number fourth, they have better service to the customers. Also, reduction of load on the host computer and reduction of delays in the data processing systems. So these were the distributed operating systems. Moving on to the next, that is network operating systems. A network operating system runs on a server and provides the server the capability to manage data, users, groups, security, applications, and other networking functions. The primary purpose of the network operating system is to allow shared file and printer access among multiple computers in a network, typically a local area network called as LAN, a private network, or to other networks. Example of network operating system include such as Microsoft Windows Server 2003, Microsoft Windows Server 2008, Unix, Linux, Mac operating system, Noble NetWare, and BST. The various advantages of network operating systems are: number one, they have centralized servers and are highly stable. Number two, security is server managed. Number third, upgrades to new technologies and hardware can be easily integrated into the system. And the last is the remote access to servers is possible from different locations and different types of systems. Also, network operating systems have some disadvantages, such as number one, high cost of buying and running a server. They are costly to install. Dependency on central location for most of the operations, and number third, regular maintenance and upgrades are required. So these are the network operating systems. Now the last are the real-time operating systems. As you can see the figure of real-time operating systems, a real-time system is defined as a data processing system in which the time interval required to process and respond to inputs is so small that it controls the environment. The time taken by the system to respond to an input and display of required updated information is termed as the response time. So in this method, the response time is very less as compared to online processing. Real-time systems are used when there are rigid time requirements on the operation of a processor or the flow of data, and real-time systems can be used as a control device in a dedicated application. A real-time operating system must have well-defined fixed time constraints, otherwise the system will fail. For example, scientific experiments, medical imaging systems, industrial control system, weapon systems, robots, air traffic control system, etc. are the example of real-time operating systems. They are basically of two types. Number one is the hard real-time system, and the number two is the soft real-time system. So number one, hard real-time systems. Hard real-time systems guarantee that critical tasks complete on time. In hard real-time systems, secondary storage is limited or missing and the data is stored in ROM. In these systems, virtual memory is almost never found. Second number is the soft real-time systems. Soft real-time systems are less restrictive. A critical real-time task gets priority over other tasks and retains the priority until it completes. Soft real-time systems have limited utility than hard real-time systems. For example, multimedia, virtual reality, advanced scientific projects like undersea exploration and planetary rovers, etc. are the examples of soft real-time systems. So these were the basic types of operating systems. Thank you.